Today we will look at the structure of water and the concepts of surface tension and viscosity. A water molecule is made up of an oxygen atom and two hydrogen atoms that are held together by covalent bonds. Oxygen is more electronegative than hydrogen, so the electrons shared between them are drawn in close to the oxygen atom. This results in one end of the molecule being slightly negative and the other slightly positive. Intermolecular forces are the attraction of molecules to each other. The attraction of molecules due to polarity is called cohesion. The cohesion of water molecules is made stronger by hydrogen bonding. This occurs when hydrogen bonds with the highly electronegative atoms of oxygen, nitrogen, and fluorine, causing it to become positively charged. The positively charged hydrogen atoms will then attract the negatively charged electronegative atoms of other like molecules, increasing the strength of cohesive forces. Viscosity is a liquid's resistance to flow. For example, water flows much more easily than honey. Therefore, it is less viscous. To compare the viscosity of olive oil, honey, and water that's been dyed red, we will see which liquid flows the fastest. Our independent variable here is the liquid used, and the dependent variable is the time it takes. The test will be repeated 3 times to increase reliability. The water reached the finish line first, followed by oil, then honey, each time the experiment was performed. This shows the order of viscosity from least to most. The round shape of water's molecules allow it to have the lowest viscosity, despite having strong intermolecular forces. The shape of the liquid's molecules plays a part in determining the viscosity. If the molecules are long and chain-like, they won't be able to slide past each other very well, increasing the viscosity, but if they are round, they can roll around each other. Also, if the intermolecular forces are very strong, they won't be able to move around each other very well, but will get stuck, increasing the viscosity. When a liquid is heated, the molecules begin to move faster, and eventually the intermolecular forces are overcome and the molecules are allowed to move freely, becoming a gas. This is why honey becomes less viscous when heated, as shown in this experiment, with warm honey on the right. When water is dropped onto a surface, cohesive forces hold the molecules together, forming a sort of skin on the outside. This is called surface tension. The surface tension of water is significantly increased by hydrogen bonds. This skin allows some things to sit on top of the water. However, if the surface tension is broken, it will peel away, propelling the object forward. If a liquid has strong cohesive forces, it will have a strong surface tension as the molecules are held tightly together. Here we will compare the surface tension of olive oil, water, and honey, the dependent variable being the number of drops released before the surface breaks and the independent variable being the liquid used. After repeating the tests 3 times, the following results were found. Although honey is more viscous, suggesting strong cohesive forces, water was capable of holding more drops. This is due to the incredible strength of hydrogen bonds. Surface tension and viscosity play important roles in our daily lives. For example, if the viscosity of toothpaste was too high, you wouldn't be able to get it out of the tube, but if it was too low, it wouldn't stay on your toothbrush. Or, when you cook a cake, the correct ratio of dry and wet ingredients must be used to produce a cake that is not too dry or wet. The outer layer of a tent serves as protection against rain, as the drops of water cannot get through the pores of the fabric. But if you touch it from the inside, the water will get through because you have broken the surface tension of the droplets on the outside.